long before there were oceans, mountains, or breath, before even the first whisper of what we now call Earth, there was only silence. A great, endless dark, punctuated by drifting clouds of dust and gas left behind from generations of dying stars. Those stars had lived their full lives, burned their fuel, and scattered their ashes across the galaxy. Elements forged in their final explosions: hydrogen, helium, carbon, iron. Their remains drifted for billions of years, waiting for a new story to begin. In a quiet corner of the Milky Way, one of those clouds began to move. It was subtle at first, a ripple, a slow spiral, drawn inward by the pull of gravity, that invisible force that writes the architecture of everything. As the cloud condensed, the gas began to swirl faster, flattening into a vast rotating disk, the solar nebula. At its heart, the pressure built so great that hydrogen atoms fused, and a new star was born, our Sun. Around it, the leftover material kept circling, billions of particles colliding, sticking together, breaking apart, and sticking again. Tiny grains of cosmic dust began to form clumps the size of pebbles. Pebbles became boulders. Boulders became mountain-sized planetesimals, wandering embryos of future worlds. Each collision released heat, melting and fusing the growing masses together. This was a chaotic ballet of creation, a storm that lasted millions of years. The young sun flared violently, sending out waves of radiation that pushed lighter gases outward, while heavier elements, like iron and nickel, sank inward. Within this chaos, one of those growing planetesimals began to dominate the others, sweeping up material in its orbit, growing larger with every pass. It didn't yet have a name, but one day it would be called Earth. If you could have floated through that newborn solar system, you wouldn't have seen blue skies or green forests, only a fiery glow, a haze of dust and molten fragments colliding under a newborn sun. The air would have been poisonous. The temperature near the surface of young Earth reached thousands of degrees. Rivers of molten rock stretched for miles, and meteor impacts were constant. Some so powerful they vaporized oceans before they could even form. And yet, in this violent beginning lay the seeds of everything to come. Every grain of dust carried the memory of ancient stars, every atom of iron in your blood, every bit of calcium in your bones, every trace of gold in your jewelry. All of it was born in that swirling cloud of starlight and chaos. In time, the dust would settle, the collisions would slow, the heat would cool just enough for something extraordinary to happen, for rock to solidify, for gravity to sculpt a sphere, and for the first foundations of a home to form. But that part of the story, the cooling of the world, the birth of oceans, and the first whispers of life, was still far away. For now, there was only motion, only light, only the soundless swirling of a young universe, dreaming of a planet not yet alive, but destined to be. The newborn sun blazed at the center of its spinning cloud, and the dust that circled it was far from still. Every fragment, from the size of a sand grain to the weight of a mountain, was drawn into an endless drift and dance of collisions. Here, gravity was both artist and destroyer. Every meeting of stones could be creation or annihilation. Within this early solar storm, countless rocky bodies orbited, crashing together at enormous speeds. Some shattered into clouds of glassy debris. Others fused in flashes of heat so bright they glowed like coals. This process was called accretion, a quiet word for something unimaginably violent. At first, it was simple physics. Smaller pieces attracted larger ones, merging into ever-growing masses. But as those bodies grew, they began to pull harder, gathering still more material. Each collision released heat, until entire worlds melted from the inside out. Across tens of millions of years, the dust became pebbles, the pebbles became boulders, and the boulders became planetesimals, the building blocks of planets. If you could have seen it then, the sky was a blur of red-hot fragments, tracing arcs of light around the young sun. The sound, if there had been air to carry it, would have been a constant, thunderous roar. Stone meeting stone, metal meeting metal, over and over, shaping the foundations of future worlds. Amid this chaos, one growing body began to stand out. It swept through its orbit like a cosmic broom, devouring smaller objects, its gravity tightening its hold on everything nearby. Each impact sent shockwaves through its molten crust, heating it further until the surface flowed like liquid fire. This was the infant Earth, still nameless, still forming, but already alive with motion and heat. Scientists believe that as the planet grew, iron and nickel sank toward the center, forming a dense metallic core. Lighter elements floated upward to create the mantle and the first thin crust. This separation would one day give Earth its magnetic shield, a defense against solar radiation, but for now, the surface was an ocean of magma, glowing beneath a red sky. Occasionally, larger planetesimals struck with such force that molten rock splashed into orbit. One of those collisions, researchers believe, was with a Mars-sized body called Theia. From that cataclysm, debris gathered and slowly coalesced again, this time into the moon. Our companion in the night sky was born not in calm creation, but in the echo of impact. As the bombardment eased, the newborn planet began to cool. Vapors condensed. Steam turned to rain. For the first time, clouds drifted above a surface that was no longer entirely molten. The crust hardened in places, forming jagged continents of black volcanic rock surrounded by vast seas of fire. In that slow cooling, something miraculous was beginning. The same gravity that had crushed and melted stone would soon pull vapor into droplets, droplets into rivers, and rivers into oceans. The Earth, shaped by destruction, was preparing for life. But that story, the first rain, the first seas, the first hint of blue in the darkness, was still waiting in the next chapter. The violence that once ruled the young planet slowly began to fade. The constant bombardment eased, and for the first time in millions of years, silence returned, though it was not the silence of peace. Beneath the hardened surface, Earth still burned. Its heart glowed with the heat of countless collisions, of radioactive decay, and of gravity's relentless pull. Deep inside, the planet began to change. It wasn't visible from the surface, but something remarkable was happening. The beginning of differentiation. The heavy elements, iron, nickel, cobalt, sank inward toward the center. The lighter ones, silicon, oxygen and magnesium, rose toward the surface. This slow migration created the first layers of the world: a molten core, a dense mantle, and a thin, fragile crust floating above. It was an invisible kind of order, written not in blueprints, but in chemistry and heat. The iron core spun, giving birth to magnetic fields that would one day protect the Earth from the solar wind. The mantle churned, vast convection currents moving like slow tides of stone. And at the surface, the thin crust cooled and cracked, forming a patchwork of islands that drifted on the molten sea below. In these early days, the sky was nothing like the blue we know. It was thick with volcanic gas, carbon dioxide, sulfur, and steam. The air shimmered with heat, and meteors still occasionally fell, carving fresh scars into the soft crust. But through it all, something extraordinary was happening. The planet was stabilizing. The temperature began to fall. The surface began to solidify. And deep within, the spinning core kept pulsing, protecting the young world from being stripped bare by the sun. Scientists believe this process, the creation of Earth's layers, took place over just a few tens of millions of years, a blink in cosmic time. But without it, the planet could never have supported oceans, atmosphere, or life. Every step toward stability was a step toward possibility. If you could have stood on that early crust, you would have felt the ground tremble constantly under your feet. The air would have smelled of metal and ash. The horizon glowed red from rivers of magma that still flowed in the distance. But for the first time, there was ground, solid, lasting ground, where before there had only been fire. This new crust, fragile as it was, would become the foundation for everything to come. The seas that would fill its basins, the continents that would rise and drift, the life that would one day crawl, swim, and breathe beneath its skies. Earth was no longer just a ball of molten stone. It was a layered world, organized, dynamic, alive with movement. And though it still bore the scars of its birth, it had finally taken its first real shape. Soon, rain would fall for the first time. Steam would turn to water, and the planet, still glowing beneath the surface, would take its first deep breath. But that breath, the moment Earth cooled enough for oceans to form, belongs to the next chapter. It has been only a few 100 million years since the sun first ignited, and Earth, though formed, is still unrecognizable. The sky is dark and thick with ash. Lightning flickers constantly through volcanic clouds. The surface below glows with rivers of molten rock, flowing like fiery oceans that never cool. This was the Hadean Ion, named after Hades, the Greek underworld, a fitting name, for the young planet was indeed a realm of fire. Volcanoes rose and fell in violent bursts. Lava seas bubbled and hissed, and each night, if night even existed under the constant orange glare, meteors streaked across the sky like burning arrows, crashing into the surface with unimaginable force. The largest of these impacts could melt entire regions, leaving behind vast craters that would one day become the outlines of continents and seas. Each strike shook the planet's crust, releasing plumes of gas into the atmosphere: carbon dioxide, methane, and water vapor. There was no air fit for breathing yet, only a heavy, toxic haze. Yet, within that chaos, something miraculous was beginning to happen. As the planet's outer layers slowly cooled between impacts, some areas hardened enough to form the earliest crust, a thin, unstable skin floating atop a restless interior. It cracked and melted again and again, but each time it returned a little stronger. This was the Earth learning to hold itself together. In the distance, the newborn moon orbited closely, far larger in the sky than it appears today. Its gravity pulled at the molten tides, stirring the surface in endless motion. The two worlds were locked together, their fates intertwined. The moon's presence helped steady Earth's rotation, preventing wild tilts that could have made the climate impossible for life. Even then, balance was being born out of violence. If you could have stood on some rocky rise, protected somehow from the unbearable heat, you would have seen no oceans, no green, no blue, only crimson horizons and glowing rivers that cut through a land of smoke. Thunder echoed across the empty plains, and the air shimmered like glass. It was beautiful in its terror, a planet still finding its form. Scientists believe this era lasted from about 4.6 to 4 billion years ago. During this time, the surface temperature could reach over 2,000 degrees. But deep inside that heat, the foundation for oceans and atmosphere was forming. Each eruption released more steam and gas, and, slowly, the heavy clouds began to thicken. When the bombardment finally slowed, the rain would come, not in drops, but in endless storms that lasted for centuries. The Hardian Aeon was not yet a world of life, but it was the prelude to it. It was Earth's long, fiery heartbeat, the sound of creation before the calm. And when the final great impact ceased, the planet exhaled. The crust cooled, the rain fell, and for the first time, a blue shimmer appeared through the clouds, the first oceans forming under the last echoes of fire. But that part, the cooling, the water, and the birth of stability, belongs to the next story. After 500 million years of thunder and fire, the young Earth began to breathe more quietly. The bombardment from space slowed. The endless rain of meteors turned from a storm into a drizzle. And beneath the dim orange sky, something no one had ever seen before began to appear. The first hints of calm. The molten rivers that once covered the planet started to cool. Where the heat eased, dark rock solidified into hard, jagged crust. Volcanoes still erupted, but now, between them, were stretches of stone that held firm, black plains that steamed under heavy clouds. They were fragile, these first crusts, cracking and reforming again and again. But they were enough to give the Earth a surface, a skin strong enough to catch the rain that was still waiting in the sky. For thousands of years, the atmosphere had been thick with vapor. The heat from below had kept it there, suspended. But as the surface cooled, the temperature fell just enough for the first droplets to form. At first, they sizzled away the moment they touched the ground. Then, slowly, they began to linger. What followed was a rainfall that lasted not days, not months, but centuries. Imagine it, the entire world wrapped in clouds, thunder echoing across continents that had no names. Rain fell endlessly, carving channels through the young crust, filling basins and craters, smoothing the jagged edges of the newborn land. Every drop that struck the hot surface released a hiss of steam, a whisper of transformation. Rock met water, fire met sky, and from that meeting came the planet's first oceans. Scientists believe these oceans formed somewhere around 4.3 billion years ago. The water may have come from many places, from the steam of volcanoes, from the icy comets that had once bombarded the Earth, even from deep minerals that released their moisture when heated. Whatever its source, the result was the same. The first blue shimmer under a still red sky. Those early seas were nothing like ours. They were acidic, dark, and heavy with minerals. But they were stable, and stability was new. For the first time, the planet had both a solid surface and liquid water, the two ingredients that one day would cradle life. If you could have looked down from space, you would have seen a world transform. The fiery glow of the Hadean Age had dimmed. Now, vast clouds swirled over dark oceans, lightning flickering through the mist. It was still a hostile place, but it was beautiful. A fragile balance between fire below and water above. And within those waters, chemistry was already beginning its quiet work. The same elements that once drifted through space, carbon, nitrogen, oxygen, iron, were dissolving, reacting, and preparing for something astonishing. In the deep, warm pools of this young ocean, the story of life itself was about to begin. The fire had quieted, and the rain had done its work. For the first time in the planet's long, chaotic infancy, there was water that stayed. The seas of early Earth stretched wide and dark, still steaming at the edges, warmed from beneath by volcanic vents, and from above by a young, restless sun. There was no life yet, no fish, no plants, no sound, only a quiet chemistry unfolding beneath the waves. The oceans were rich with minerals drawn from the cooling crust: iron, sulfur, carbon, nitrogen. Lightning still flashed across the sky, sending energy crackling through the atmosphere. Each strike tore molecules apart, only for them to reform into new shapes. Simple at first, then more complex. In this restless sea, the first ingredients of life began to take form. Scientists call it the primordial soup, a poetic name for a mix of gases and liquids that became the foundation of biology. Experiments in the 20th century, like the famous Miller-Urey experiment, recreated some of these early conditions in a lab. When sparks of electricity passed through a mix of water vapor, methane, and ammonia, something extraordinary happened. Amino acids, the basic building blocks of life, appeared. It's hard to imagine such a thing. A world without purpose or design, only chemistry following its own quiet rules, somehow giving rise to the ingredients of life. Perhaps it began in shallow pools, where evaporation concentrated the chemicals. Perhaps in the deep ocean, near volcanic vents that spewed minerals and heat. Either way, Earth had become a vast natural laboratory, and time was its patient scientist. Over millions of years, the molecules grew more elaborate. Simple compounds linked together into chains, forming proteins, lipids, and nucleic acids. They floated, drifted, combined, broke apart, and combined again. Most of these early experiments failed, but a few endured just long enough to copy themselves, and in that simple act, everything changed. That first self-replication was the dawn of life's long story. It wasn't a creature, or even a cell, just a cluster of molecules that learned to make a version of itself before falling apart. But from that one principle, copy, vary, survive, would come everything: forests, birds, humans, and the memories we call history. If you could have looked into those early waters, you wouldn't have seen movement or color, just a dim glow from thermal vents, a shimmer of bubbles, and the slow dance of invisible reactions. But in that darkness, life's first whispers were forming. The planet that once burned now stirred with potential. No one can say exactly where or when that spark first took hold. Perhaps it happened more than once, in more than one place, over millions of years. But once it began, it never stopped. Life found a way, quietly, persistently, beautifully. And soon, these invisible chains of molecules would grow bolder. They would build walls around themselves, form the first true cells, and begin to shape the world forever. That story of the first living cells and the dawn of biology begins next. For hundreds of millions of years, life existed quietly in the oceans, hidden in darkness. Tiny, single-celled beings drifted with the tides, feeding on the chemicals that seeped from volcanic vents. But one group of these ancient microbes began to do something different, something that would change everything. They learned to use light. These were the ancestors of cyanobacteria, often called blue-green algae, though they were not algae at all. They were simple, but their discovery was profound. Sunlight could be turned into energy. Through a process we now call photosynthesis, they used the energy of the sun to take in carbon dioxide and water, and in return, they released oxygen. At first, this new gas went unnoticed. The oceans quickly absorbed it, reacting with iron and other elements dissolved in the water. But as millions of years passed, the iron was used up. The oxygen began to accumulate, first in the sea, then in the air. And slowly, almost imperceptibly, the color of the world began to change. The iron-rich oceans turned from green to blue. The rocks at the seafloor rusted, leaving behind layers of red that we still find in ancient formations today. Banded iron stones, the fossilized fingerprints of a world learning to breathe. Scientists call this transformation the Great Oxidation Event, and it began around 2.4 billion years ago. It was not a single moment, but a long unfolding, a billion-year rise of oxygen that would prepare the planet for complex life. But it was not peaceful. For the microbes that had once thrived without oxygen, this new gas was poison. Many died. Some retreated into deep, oxygen-free environments that still exist in parts of the ocean today. Yet others adapted, using oxygen as a powerful new fuel, the beginning of aerobic life. For Earth, the change was staggering. The atmosphere thickened with oxygen and ozone, shielding the planet from harmful ultraviolet rays. Temperatures began to stabilize. For the first time, sunlight could reach the surface without destroying what it touched. And beneath that calmer light, life began to diversify. If you could have seen it, the planet would still seem empty. No trees, no animals, no sound but the wind over the waves. But under those waters, a silent revolution was in motion. Each tiny cell, multiplying by the trillions, was rewriting the chemistry of the world. Every breath you take today, every flame that burns, every heartbeat that beats, exists because of what they began. The Earth was no longer a planet of stone and fire. It was a living world, wrapped in its own breath. The blue sky we know today began here, born from the quiet labor of microscopic pioneers, working unseen in an ancient sea. And with oxygen came opportunity. Cells could now grow larger, more complex, and more connected. From this invisible transformation would come a new kind of life, one that carried within it the seeds of all future creatures. That next step, the birth of complex cells, the eukaryotes, was about to begin. The blue-green world of early Earth was beautiful, but beneath its calm surface, something monumental was brewing. The cyanobacteria had filled the oceans with oxygen, turning sunlight and water into the chemistry of life. But oxygen, though gentle to us now, was a dangerous newcomer in that ancient time. To the early microbes that had thrived in a world without it, this new gas was poison. And as it spread through the oceans and sky, it brought the planet to the edge of ruin. For millions of years, the oxygen went unnoticed, absorbed by iron in the seas and rocks. But once the oceans could hold no more, it began to leak into the atmosphere. At first, it was just a whisper, a thin layer of gas rising above the waves. Then, over millions of years, it thickened into a veil that wrapped the Earth in something entirely new, an oxygen-rich sky. The transformation was slow, but its effects were profound. Many of the ancient microbes, the anaerobes, began to die out. Whole ecosystems vanished, suffocated by the very element that would one day sustain us. To them, oxygen was not life. It was fire. It damaged their delicate chemistry, breaking apart the molecules they relied on. This silent apocalypse is what scientists call the Great Oxidation Event, about 2.4 billion years ago. It was the planet's first mass extinction, a cleansing that reshaped everything that came after. Yet, from that devastation, a new kind of life emerged. Organisms that learned not just to survive oxygen, but to use it. They evolved complex machinery inside their cells, turning oxygen into energy with astonishing efficiency. This was the dawn of aerobic respiration, the same process that fuels every breath we take today. The rise of oxygen did more than change biology. It altered the climate itself. Methane, once abundant and warming the planet, reacted with oxygen and vanished, plunging Earth into its first great ice age. Glaciers spread from the poles toward the equator. For millions of years, much of the planet was locked in ice, a frozen sphere shining faintly under a pale sun. Scientists call this the Huronian glaciation, and it may have lasted nearly 300 million years. And yet, even in that cold, life endured. Some microbes found refuge beneath the ice, near volcanic vents, or deep in the crust, where heat and minerals still flowed. Others adapted to the new oxygenated world, evolving faster, diversifying, exploring chemical pathways that had never existed before. When the ice finally began to melt, the world that emerged was unrecognizable. The air was clear and blue. The oceans sparkled with light. And in that brightness, new forms of life began to stir, larger, more complex, and full of potential. The Great Oxidation Event was both a disaster and a rebirth, a reminder that progress often begins in chaos. Earth had burned, frozen, and nearly died. But from its trials, it emerged stronger, cleaner, and ready for the next great leap. The rise of complex cells, the eukaryotes, and the first true steps toward the living world we know. When the Earth finally thawed from its long frozen silence, life was waiting. Tiny survivors, simple cells that had learned to live with oxygen, began to multiply once again in the oceans. They found sunlight in the shallows, warmth from the vents below, and minerals drifting through the currents. The world was no longer hostile, but still empty, a blank canvas ready to be painted by life's slow persistence. These microbes gathered wherever conditions allowed, along shorelines, tidal flats, and shallow pools warmed by the newborn sun. As they grew, they clung to one another in sticky films, forming layered communities known as microbial mats. Each mat was a living city, millions of cells packed together, performing their quiet daily work. Some captured sunlight through photosynthesis. Others consumed the waste left behind. Each layer served its purpose, and together they formed a balance more intricate than anything the planet had ever known. Over time, these living carpets began to shape the very land beneath them. As the mats trapped dust, sediment, and minerals, they hardened, layer upon layer, into structures called stromatolites. They looked like small stone domes, rising from the seafloor like ancient coral reefs. But inside, they were alive, pulsing with microbial life just beneath their rocky skins. Every new sunrise added a new layer, and as the centuries passed, they grew upward, recording each day like pages in a geological diary. Some of the stromatolites that formed during this time, more than 3 billion years ago, still exist today in places like Shark Bay, Australia, and the coastlines of Western Australia's Pilbara region. They are among the oldest living structures on Earth, direct descendants of the planet's first communities. To stand beside them is to stand beside the ancestors of everything that would ever live. These early ecosystems did more than simply survive. They began to engineer their environment. The oxygen they released continued to fill the air and poured water. The sediments they trapped built the first stable seafloors. The nutrients they recycled paved the way for more complex life to follow. In their slow, invisible way, they were architects, transforming chaos into order and setting the stage for evolution to accelerate. If you could drift above one of these ancient reefs, you might see ripples of light dancing across a shallow sea, the water tinted green and gold. Beneath the surface, tiny filaments shimmered as they turned sunlight into energy. No sound, no movement, just the quiet pulse of life, breathing through the ages. For billions of years, these microbial worlds would dominate the planet, shaping its air, its chemistry, and its destiny. Every breath of oxygen, every blade of grass, every creature that would ever walk the land, all trace their origin to these silent mats of life. The Earth was no longer just a planet of rock and water. It had become a living world. And though the creatures were small, their legacy was vast, the foundation upon which all future life would stand. The next chapter of the story would belong to complexity, to cells that joined forces, to multicellular life, and to evolution's grand leap forward. For billions of years, Earth's oceans were ruled by simplicity. Tiny, single-celled organisms drifted beneath the waves, endlessly dividing, eating, and releasing oxygen into the growing sky. It was a quiet world, patient, stable, and ancient. But life, even in its smallest forms, is never truly still. And after nearly 2 billion years of repetition, something began to change. Among the countless prokaryotic cells, simple, nucleus-free pioneers, a few began to experiment with cooperation. Some swallowed smaller cells, not to digest them, but to keep them alive inside. At first, it was an accident, a fluke of chemistry. But for those that survived, the partnership proved powerful. The swallowed cells provided extra energy, and the larger cell offered protection. Together, they became something new. This was the dawn of the eukaryote, a cell with a nucleus, with internal compartments, with a blueprint for complexity. It was a quiet revolution, one that would eventually give rise to plants, animals, fungi, and us. Inside these new cells, the genetic material was safely stored within a membrane, the first nucleus. It was like a control center, separating instructions from the chaos of the surrounding chemistry. Other compartments soon followed: miniature power stations, waste recyclers, and transport systems. Each structure had a role, and together they turned a single cell into a living city. The most important of these inner symbionts were the mitochondria, tiny energy converters that once lived freely on their own. They were the descendants of ancient bacteria, and when they were absorbed into the eukaryotic cell, a miracle of efficiency was born. Instead of relying solely on sunlight or raw chemicals, these new cells could harvest energy directly from oxygen, powering far greater growth and complexity. This quiet partnership, one cell living inside another, is one of the most astonishing examples of cooperation in nature. It's a reminder that evolution is not only about competition, but also about connection. Where earlier life had fought simply to survive, these new forms learned to share. Over time, eukaryotes diversified. Some stayed single-celled, like the ancient algae that still drift through today's seas. Others began to join together, forming colonies, simple groups that communicated, specialized, and moved as one. It was the first whisper of multicellularity, the blueprint for everything that would follow. If you could drift through those early oceans, you might not notice anything at first. The water would look the same, clear, blue, and empty. But under a microscope's eye, the difference would be breathtaking. Inside each eukaryotic cell shimmered a universe of motion. Tiny threads spinning, membranes pulsing, molecules dancing in ordered harmony. It was as if life itself had discovered architecture. This new complexity changed everything. It allowed for larger bodies, faster adaptation, and more intricate relationships between organisms. The stage was being set for the next great expansion, when life would no longer be confined to the sea, and diversity would explode in forms the world had never seen before. The Earth was ready for its next transformation. The quiet, single-celled age was ending. And the age of complexity, the age of life as we recognize it, was about to begin. For billions of years, life had been a world of solitude. Every creature was a single cell, living, feeding, and dividing in quiet repetition. The oceans shimmered with uncountable individuals, but each existed alone. And yet, deep within that simplicity, something new was stirring, an ancient instinct to connect. It began, perhaps, with simple cooperation. Some single-celled organisms found that staying close offered safety. Clusters of identical cells would float together, clinging to one another after dividing instead of drifting apart. At first, this connection was temporary, a brief alliance in the currents. But in time, it became permanent. Cells began to specialize. Those on the outside learned to sense danger or light. Those within focused on reproduction or protection. This division of labor created the first multicellular organisms, groups of cells so interdependent that they could no longer survive apart. It was one of the greatest transitions in the history of life, the moment individuality gave way to unity. From colonies of algae to sponges, worms, and beyond, the pattern was set: cooperation as evolution's new language. If you could have seen those early multicellular forms beneath the ancient seas, they would look strange. Soft ribbons, tiny clusters, filaments that shimmered like silk in the dim sunlight. They had no eyes, no organs, no bones, just networks of cells moving in rhythm, breathing as one. And yet, within them, the blueprint of every future plant and animal was being written. The advantages were immense. Together, cells could grow larger, move more efficiently, and adapt faster to change. They could develop internal communication, chemical signals that allowed them to coordinate their behavior, like a tiny brain made of shared purpose. For the first time, life could build bodies, structures capable of moving through water, capturing energy, and protecting themselves from danger. This was the beginning of true diversity. From these simple clusters would come every branch of complex life, from seaweed to coral, from fish to mammals, from the smallest insect to the human heart. Scientists believe this transition began at least 1.2 billion years ago, with red algae and other early multicellular eukaryotes. Over hundreds of millions of years, these forms experimented endlessly, splitting, merging, adapting, until a balance was found between cooperation and individuality. Even today, within our own bodies, the echoes of that first unity remain. Each of us is made of trillions of cells, all descendants of those early pioneers, living, communicating, and sacrificing for the good of the whole. It's humbling to think that the story of complex life began not with conquest, but with connection, not with dominance, but with trust. Each cell gave up a little independence so that something greater could exist. And from that choice, the tapestry of life began to bloom. Soon, the oceans would be filled with color and motion, new creatures exploring every shape imaginable. It was the dawn of diversity, and it would change the face of the planet forever. The oceans, once dim and grey, slowly began to bloom with color. For the first time in billions of years, sunlight didn't just warm the waters. It was captured, transformed, and stored as living energy. From tiny green cells drifting near the surface came vast sheets of algae, painting the seas with emerald and gold. The planet, for the first time, began to glow with life. Algae were among the earliest multicellular eukaryotes, simple, flexible, and perfectly tuned to sunlight. They learned to live in colonies, linking together into long filaments and soft mats that floated like gardens beneath the waves. Each cell played its part. Some absorbed light, others anchored the colony or helped it reproduce. Together, they turned the oceans into the first true ecosystems, where light and chemistry danced in delicate balance. These ancient algae were the world's first oxygen factories, building on the work begun by cyanobacteria billions of years before. They expanded the atmosphere, enriching the air and deepening the blue of the sky. And in their shadows, other organisms evolved, small grazers, predators, and scavengers that depended on this new green abundance. But another quiet partnership was forming, one that would change life forever. In the darkness beneath the sea floor and on damp coastal rocks, algae met fungi. The fungi couldn't make their own food, but they were masters of absorption, drawing nutrients from the minerals around them. The algae, in turn, provided sugars made from sunlight. Together, they formed a partnership, a living alliance that could survive in places neither could endure alone. These were the ancestors of lichens, and their cooperation opened the door to the land itself. Slowly, these ancient partnerships crept from the sea to the shoreline. The waves still ruled most of the world, but tiny colonies began to cling to wet rocks, surviving the tides and drying winds. Over millions of years, these pioneering organisms adapted, growing tougher cell walls, developing structures to store water, and protecting their delicate chemistry from the harsh sunlight above. Out of these humble beginnings arose the first plants, small, moss-like forms that clung to damp surfaces, breathing through thin leaves and spreading their spores into the wind. They had no roots, no flowers, no stems, only courage and time. Yet from these fragile forms would come forests, grasslands, and every green thing that would ever touch the sky. If you could have walked along those first shores, you'd see a world half-born, the ocean glimmering with colour, the rocks veiled in green films that swayed gently in the breeze. It was quiet, patient, and full of promise. The planet was transforming once again, from a blue world to a living, breathing one. The algae had painted the seas, the fungi had built the bridge, and the first plants had crossed it. Soon, life would no longer be confined to the water. It would rise, stretch, and reach for the sun. The age of the green world was just beginning. For billions of years, life had remained invisible, small, simple, and quiet. The oceans were full of cells, filaments, and soft-bodied forms that drifted without eyes or bones. But then, around 541 million years ago, something changed. In a span of just a few tens of millions of years, a heartbeat in geologic time, the oceans transformed. The silence broke, the world filled with movement. This was the Cambrian explosion, the moment when life discovered form. Creatures began to grow shells, legs, mouths, and eyes. The simple became complex, the soft became armored, and evolution, which had crept for eons, suddenly sprinted forward. No one knows exactly why. Perhaps oxygen levels finally rose high enough to fuel larger bodies. Perhaps the chemistry of the seas reached a perfect balance. Or maybe life had simply reached a tipping point, an explosion of creativity after endless quiet preparation. Whatever the reason, the earth blossomed. The seafloor teemed with colour and motion. Worm-like creatures burrowed through the mud. leaving trails that still mark the rocks today. Jellyfish drifted through the upper waters, translucent and graceful. And stranger beings appeared, spiny trilobites with gleaming eyes, feathered fronds called anomalocarids that glided like ancient dragons, and armored worms that crawled across the seabed with rows of glittering spikes. For the first time, predators hunted and prey fled. The balance of nature, the push and pull of survival, had begun. Creatures that evolved eyes could sense danger and light. Those with shells could defend themselves. Evolution became a grand experiment in design, nature testing every shape, every idea, every possible way to live. If you could swim through a Cambrian sea, it would feel like entering another world. The water shimmered with the light of the early sun. Coral-like structures reached upward. Small, finned creatures darted between shadows, their movements quick and deliberate. For the first time, life had purpose. Not conscious purpose, but energy, direction, drive. The will to move, to seek, to endure. Scientists call this time the biological Big Bang, because almost every major group of animals alive today traces its ancestry back to this period. The roots of insects, fish, reptiles, and even mammals all began as experiments in those ancient seas. Each form that succeeded passed its story forward, written in DNA, refined over ages of trial and adaptation. Yet even in this burst of creation, many vanished. Evolution is generous, but not kind. Of the countless shapes that filled the Cambrian seas, most disappeared without descendants. But those that endured carried the memory of that golden time, when life learned to build bodies, to sense the world, and to explore it. The earth had awakened. The seas were alive with form and purpose, and soon those living waves would surge outward, spreading to new realms, climbing toward light, and forever changing the face of the planet. The Cambrian seas shimmered under the ancient sun, full of movement, color, and quiet energy. Life, once invisible, now filled every layer of the water, from the seafloor to the light-filled shallows above. It was a world of shells and eyes, of predators and prey, of delicate forms that drifted and hard shells that crawled. The earth, for the first time, was truly alive with animals. Among the most successful were the trilobites, small, armored creatures that looked like a cross between beetles and horseshoe crabs. Their bodies were divided into segments, each protected by a curved shell that gleamed like polished stone. They scuttled across the seafloor in endless numbers, feeding on detritus, burrowing into the sand, and sometimes becoming prey themselves. Their compound eyes, among the first in nature, could see in multiple directions, giving them a view of a world that had never been seen before. Trilobites would go on to dominate the oceans for nearly 3 million years, leaving behind millions of fossils that still sparkle in stone today. They were nature's first great success story, adaptable, resilient, and beautifully designed. But they were not alone. The seas of this age were full of strange wonders. Flat, frilled Wiwaxia glided over rocks like jeweled carpets, their bodies covered in soft spines. Long, tubular worms wriggled through the mud, their flexible bodies leaving winding trails behind them, the first true engineers of the seafloor. Some, like the preapulid worms, were simple predators, lying in wait to snatch smaller creatures that drifted too close. Others helped turn the sediment, creating nutrient-rich habitats where more life could thrive. In deeper waters, elegant swimmers called anomalocarids, the apex predators of their time, patrolled the currents. With grasping limbs and a mouth like a spiral of blades, they hunted trilobites and other early animals, shaping the first food webs in Earth's history. For the first time, evolution had created both hunter and hunted, and the balance between them would define life forever. These ancient animals lived in worlds of soft coral, seaweed forests, and limestone ridges. Some attached themselves to rocks and filtered food from the water. Others swam freely, exploring every corner of the sea. They built the first true ecosystems, networks of life connected by energy, adaptation, and time. And yet, even in their abundance, these creatures were fragile. The Earth's climate shifted often. Continents moved. Seas rose and fell. Each change wiped away some species and gave rise to others, slowly refining life's endless experiment. If you could close your eyes and imagine drifting through those ancient waters, you'd see a world both alien and familiar, a flicker of sunlight through green depths, shadows moving below, the slow rhythm of life discovering itself. It was peaceful, yet full of motion, a harmony between chaos and design. The Cambrian world would not last forever, but from its oceans came the ancestors of every animal that would ever walk, fly, or dream. The Earth had learned the art of creation, and it would never forget it. For billions of years, the continents had been silent. Bare stone stretched to the horizon, mountains, deserts, and plains of rock, carved by wind and rain, but untouched by life. Only in the oceans did color exist, where algae and strange creatures danced beneath the waves. The land waited, empty, for its first pioneers. Then, sometime around 470 million years ago, a green shimmer began to appear along the shorelines. It started small, films of algae clinging to wet rocks, surviving the tides and drying winds. These tiny, fragile colonies were the first to bridge the boundary between water and air. Every time the tide fell, they endured a little longer. Every generation adapted a little better through countless cycles of trial and survival. These early algae transformed. They developed coatings to hold in moisture, filaments to anchor them, and tissues that could carry water upward. They became the first mosses, soft carpets of green that spread across the edges of the continents. They had no roots, no flowers, no seeds, just patience. They absorbed rain, clung to stone, and slowly began to change the face of the world. The air, once dry and harsh, grew softer as mosses trapped moisture and built the first soils. They broke down rock into fine particles, preparing the ground for the next wave of life, the ferns. These plants grew taller, their leaves unfolding like delicate feathers. They carried water through slender veins, reaching for light with a confidence the mosses had never known. Their fronds captured sunlight and released oxygen, filling the air with the breath of forests that did not yet exist. Soon, the world was covered in green. Ferns and their relatives, horsetails and club mosses, formed vast wetlands. Their spores drifted on the wind, spreading across continents. For the first time, the land was alive with movement. Not fast or loud, but steady, unstoppable. Then came another revolution. The seed. Tiny, protective capsules that carried the future inside them. Where spores needed constant moisture to grow, seeds could wait. Dry, patient, and strong. They could travel far from water, carried by the wind or by chance. With seeds, plants no longer depended on the tides. They could conquer the uplands, the valleys, the mountains, every corner of the earth. The first seed plants, the ancestors of conifers and flowering plants, brought permanence to the green world. Forests rose, casting shade over rivers that had once flowed in the open. Roots split rock and stabilized the soil. The atmosphere filled with oxygen, cooling the planet and inviting new forms of life to follow. If you could have stood on one of those early hills, you would see a world reborn. The grey stone of ancient earth now veiled in emerald. The wind whispering through ferns. The air heavy with scent and life. The land, once silent, now breathed. And soon, other creatures would answer that call, the first to crawl from the sea and walk upon the green. The world was green now, oceans of moss and fern stretching from valley to mountain, a living skin wrapping the continents. Moisture clung to the air, and oxygen levels soared higher than they would ever be again. And where plants spread, animals followed. The first to claim the land were not the mighty reptiles or the ancient fish, but the small, armored arthropods, creatures with hard shells and jointed legs. Their ancestors had crawled the seafloors for hundreds of millions of years, as trilobites and crabs. Now, drawn by new food and new opportunity, they crept onto the shore. They came in many forms, millipede-like scavengers, feeding on fallen leaves, spider-like hunters waiting in shadows, and tiny explorers venturing through the forest litter. Their shells protected them from the dry air. Their segmented bodies allowed them to move with ease, and their curiosity drove them into every corner of the new green world. Soon, the land was alive with their motion, a quiet rustling beneath the ferns. But one group among them did something no creature had ever done before. They took to the air. The first insects appeared around 400 million years ago, and within a few short ages, they discovered flight. Their wings were thin and delicate, veined like leaves, shimmering in the sunlight. No one knows exactly why they evolved, perhaps to escape predators, or to find new food, or simply to explore the sky. Whatever the reason, the effect was astonishing. The forests, once silent but for the wind, began to hum. Dragonflies with wings as wide as a hawk's glided over ancient swamps. Mayflies danced in clouds above the water, living their brief, beautiful lives in the sunlight. Beetles scuttled across bark, while centipedes hunted among the roots. It was a world of motion, of shimmer, of delicate sound. High oxygen levels made the air dense and rich, perfect for these creatures to grow to extraordinary size. Some dragonflies reached nearly a meter across. Centipedes longer than a human arm moved through the undergrowth. The earth had entered the age of arthropods, a time when the small became mighty, and the air itself became a highway of life. They ruled the land with quiet efficiency. They were recyclers, pollinators, builders, and hunters. They helped break down the fallen leaves, fertilize the soil, and spread the spores and seeds of plants. In a very real sense, they became the planet's first gardeners, shaping ecosystems long before any mammal or bird. If you could walk through those primeval forests, you would hear the soft buzz of wings and the faint crunch of shells beneath your feet. It would feel alive in a way the planet had never felt before. Every shadow moving, every tree alive with motion. The insects had discovered a freedom no creature had known before, the freedom of the air. And soon, other beings would watch them and dream of that same gift. For from the swamps and rivers below, another transformation was already stirring. The moment when creatures of the sea would crawl onto the land and take their first steps toward the future. Long before footprints marked the earth, the oceans were full of movement. The seas swarmed with life, trilobites crawling, fish gliding, and ancient invertebrates filtering sunlight through the shallows. But beneath the green waves, something new was stirring. Creatures with spines, bones, and the first faint promise of strength. These were the early vertebrates, distant ancestors of every animal with a backbone. They began as simple swimmers, armored fish with plated heads and tails that moved like ribbons through the water. Their skeletons were made of cartilage, soft and flexible. But with time, bone began to form, strong enough to support muscle, to move against gravity, to push. Among them were the placoderms, great armored fish that ruled the Devonian seas about 100 million years ago. They were hunters, explorers, and survivors, some growing longer than 3 meters, their jaws among the first capable of a true bite. They fed, fought, and thrived in the vast warm oceans of their time. But in the quiet shallows near the coasts, smaller, more curious fish began to experiment with something new. These fish had fleshy, muscular fins with bones. They belonged to a group called the lobe-finned fish, and among them were the ancestors of all amphibians, reptiles, birds, and mammals. Their fins were strong enough to push through the mud, to brace against rocks, and to hold their weight in shallow water. One of them, a fish we now call Tiktaalik, shows the first evidence of a neck, wrists, and lungs. Tools for a future it could not imagine. The land above must have seemed strange and dangerous, hot, bright, and silent. But it also offered something the sea could not: opportunity. Fewer predators, still pools full of insects, and air rich in oxygen. Step by slow, careful step, these ancient pioneers began to explore. They did not march out of the sea all at once. It was a gradual crossing, millions of generations testing the edge of the tide. Each visit to land lasted a little longer. Each adaptation, stronger bones, thicker skin, better lungs, was a small victory. Until, one day, the water behind them was no longer their home, but their memory. If you could have watched one of those early amphibians crawl from the shallows, you'd see a creature both awkward and magnificent. Its fins flexing like hands, its gills fluttering as it gasped for air. Each movement uncertain, yet determined. The first heartbeat of life on land. The Devonian is often called the Age of Fishes, but it was also the dawn of something greater, the beginning of all terrestrial life. From these first steps would come reptiles, mammals, and eventually us. The oceans had birthed the world's first explorers. Now the land had its first inhabitants, and in their slow, clumsy crawl, they carried the future of life itself. The first creatures to crawl from the sea were fragile, part fish, part wanderer, still tied to the water that had birthed them. They could breathe the air, but only for a time. They could walk, but not far. These were the amphibians, Earth's first pioneers of the in-between, living where water kissed the land, where swamps shimmered beneath fern-filled skies. The Devonian seas faded into the Carboniferous Age, a world of warmth, humidity, and endless green. Forests towered high with tree ferns, club mosses, and horsetails thicker than a man's arm. The air was heavy with oxygen, and these earth breathed like a living lung. In these steaming jungles, the amphibians flourished. They grew large, some over 2 meters long, their broad heads breaking the surface of still ponds, their eyes glinting in the half-light. They ruled the rivers and swamps, feeding on insects the size of birds. But evolution never stands still. The land was rich, the air abundant, and some creatures began to push farther from the water. They developed new skins that did not dry in the sun, lungs that could last a lifetime above the waves, and eggs with hard shells that could survive on land. These were the reptiles, the first true masters of the dry world. It was a quiet revolution, the birth of independence from the sea. For the first time, animals could live entirely on land, building nests beneath the trees, basking in the warmth of the young sun. They spread across the continents, taking on forms both familiar and strange. Some scurried through undergrowth. Others grew massive, armored, and strong. The Carboniferous forests trembled with the footsteps of these new conquerors. From them would rise the synapsids, distant ancestors of mammals, and the sauropsids, who would one day become dinosaurs. The Earth was entering an age of giants. Gigantic dragonflies filled the skies with shimmering wings nearly a meter across. Millipedes the length of cars crawled through the damp forests. Amphibians lounged in the shallows, their ribbed sides rising and falling like bellows. And in the drier lands beyond, reptilian shapes began to dominate the horizon. By the end of this age, continents were colliding to form Pangaea, a single, vast supercontinent surrounded by endless ocean. With it came new climates, new challenges, and new opportunities. The once swampy world began to dry. Forests retreated, amphibians dwindled, retreating to rivers and marshes. But the reptiles, with their scaly armor and sunlit blood, thrived. They grew larger, faster, more diverse. They learned to run, to bite, to hunt. Some took to the skies. Others returned to the water, this time as masters, not refugees. The balance of life had shifted once again. The amphibians had been the bridge, but the reptiles became the empire. And in their shadow, Earth entered a new and powerful era, the age of titans, of thunder, of dragons, that would one day rule the world. The age of giants had begun. For millions of years, the world had been vibrant. Forests stretched from pole to pole. Reptiles ruled the land. Amphibians filled the rivers. And insects hummed in the thick, warm air. It was a golden age, lush, teeming, alive. But beneath that beauty, the earth was stirring. And what came next would be the greatest catastrophe life had ever faced. It began quietly, deep beneath the crust of the planet. In what is now Siberia, enormous volcanic eruptions tore open the earth. Lava poured across the land for millions of square kilometers. The Siberian traps, releasing unimaginable amounts of carbon dioxide and methane into the atmosphere. The sky darkened with ash. Acid rain fell upon the forests. The seas began to warm. At first, life endured. The forests burned and regrew. Animals fled and returned. But the damage was relentless. The oceans absorbed the carbon, growing hot and suffocating. Oxygen levels dropped until vast stretches of water turned deadly, stagnant and poisonous. Coral reefs collapsed, the air filled with toxins, and slowly, across the face of the world, everything began to die. It happened about 252 million years ago, at the end of the Permian period, in what scientists now call the Great Dying. Nearly 90% of all marine species and 70% of land species vanished. Entire forests disappeared in a single geological moment. The buzzing of insects ceased. Even their resilient kind could not survive. The very sound of the planet seemed to stop. If you could stand on Earth then, the silence would be unbearable. No birds, they did not yet exist. No leaves whispering in the wind. Only blackened stone, endless heat, and the faint hiss of dying oceans. The great reptilian empires were gone. The once mighty amphibians were reduced to a handful of survivors clinging to damp refuges. The air itself was thin and toxic. For the first time in hundreds of millions of years, it seemed as if life's story might end. And yet, it didn't. In the shadows of extinction, small things endured. Tiny, burrowing reptiles. Simple ferns that sent up green shoots through the ash. Microbes that thrived in the heated seas. From their persistence, the world began again. It took millions of years for recovery, an entire age to rebuild what had been lost. But life is resilient. The survivors adapted to the changed world, learning to live in its heat and its emptiness. And from their descendants would rise new lineages, tougher, faster, stranger. Among them, the first ancestors of dinosaurs. The Permian extinction was the end of one world and the beginning of another. The reset that allowed evolution to reinvent itself. And when life returned, when forests grew again, when creatures filled the seas and skies, the world they built would look nothing like the one that came before. The age of reptiles was about to begin, and from the ashes of silence, the world would roar again. The world that rose from the ashes of the Permian extinction was a quieter place. For a time, the earth seemed almost empty, its forests thin, its skies pale, its oceans hushed. But beneath that silence, something was stirring. The planet was healing, and life, as it always had, was beginning again. The continents were fused together into a single vast land, Pangaea, a world of endless horizons. Across it stretched red deserts, steaming swamps, and young forests of ferns and cycads. The air was hot and dry, and the seasons were harsh. But through this new world, survivors moved. Small reptiles, amphibians, and insect-like scavengers, each testing the fragile balance of the reborn Earth. Among them walked the archosaurs, a new kind of reptile built for the changing world. They stood taller, with stronger legs that lifted their bodies off the ground. They breathed deeply, efficiently, their hearts and lungs working together to endure the heat. Some would become crocodiles, others pterosaurs, the first flying reptiles, and a few, almost unnoticed, would become something far greater. From the archosaurs came a slender, two-legged creature, no larger than a dog. Its name, Eoraptor, meaning dawn thief. It hunted small prey in the shadow of ancient conifers, quick and alert. Its bones were light, its movements precise, its eyes sharp. It was one of the first dinosaurs, and though it looked ordinary, it carried within it a design that would rule the world for the next 160 million years. These early dinosaurs were not giants. They were survivors, small, agile, warm-blooded hunters who thrived in a world still unstable. While other reptiles basked lazily in the sun, these new creatures were active, alert, and endlessly adaptable. They laid eggs with shells that could survive dry conditions. They moved swiftly on powerful legs, and they traveled in groups, suggesting a hint of intelligence that set them apart. The Triassic world slowly filled again with life. Forests thickened, rivers returned, and the air grew rich with the breath of plants. Amphibians once again filled the swamps, while reptiles ruled the dry lands. Strange creatures roamed the deserts. Long-necked Plateosaurus, sharp-toothed Coelophysis, and armored Etosaurus crawling like living tanks through the undergrowth. Everywhere, evolution was experimenting. And the dinosaurs, still few in number, were learning how to thrive. Then, around 230 million years ago, a shift began. Volcanoes rumbled once more, reshaping the climate. Old predators vanished, and the dinosaurs seized the opportunity. They spread across Pangaea, from forest to desert, from pole to equator, adapting to every environment the planet offered. What began as small, quick hunters became towering herbivores, graceful predators, and creatures that would dominate the Earth in form, color, and sound. If you could stand on that Triassic plain, you would see a new kind of world. Red dust beneath your feet, strange calls echoing through the trees, and, in the distance, the delicate imprint of a clawed foot pressed into the soft earth, the first step of an empire that would last for an age. The dinosaurs had arrived, and the world would never be the same again. The Triassic world had ended in fire. Volcanoes tore through the supercontinent, and once again, extinction swept across the face of the Earth. But from the smoke and silence rose a new world, greener, wetter, fuller. The continents began to drift apart, and with the change came new coastlines, new rains, and new life. The Earth was entering the Jurassic period, an age of growth, of warmth, and of giants. Forests spread across the continents, thick with towering conifers, ferns, and cycads. Where deserts once stretched endless and red, jungles now shimmered with mist. The air was heavy with oxygen and the scent of resin. Rivers coiled through valleys, feeding wetlands alive with frogs, turtles, and insects whose wings glittered in the light. It was a paradise built for size. And into that paradise stepped the sauropods, the largest creatures ever to walk the land. Their necks rose like living towers, swaying gently as they reached for the treetops. Their tails stretched behind them, balancing their massive bodies with the grace of ships at sea. Brachiosaurus, Diplodocus, and Apatosaurus, names whispered through stone, drank from ancient lakes, and moved in herds so vast that the ground itself seemed to breathe beneath them. Their size was not a burden, but a triumph. The lush vegetation of the Jurassic could sustain them, and their enormous lungs and efficient hearts carried oxygen through bodies that dwarfed every predator. Each footstep pressed a memory into the soft earth, marks that would remain for millions of years. Around them, the forests echoed with other lives. Armored stegosaurs moved slowly through the ferns, their plates catching the sun like bronze shields. Small, quick dinosaurs darted through the undergrowth, early relatives of birds, covered in downy feathers that shimmered with color. And above it all, the pterosaurs ruled the skies, their leathery wings cutting through the warm air as they glided between cliffs and canopies. Predators evolved to match this abundance. Sianosaurus, Allosaurus, and other early giants stalked the herds, their senses sharp, their movements deliberate. They hunted in packs or alone, guided by instincts honed over millions of years. The age of the dinosaur had reached its golden height, a balance between predator and prey, forest and field, earth and sky. If you could walk through a Jurassic Valley, the world would feel alive in every direction. The air would tremble with the low calls of sauropods. Mists would drift between colossal trunks. Dragonflies would flit through beams of sunlight, and the ground beneath your feet would still bear the warmth of the last great herd. It was a time of peace and majesty, not in silence, but in harmony. The earth had found its rhythm again, and for nearly 60 million years, the song of life played strong and steady beneath the green. But far away, deep in the oceans and within the restless crust, the next act of change was already preparing. The giants ruled, yes, but even empires carved in stone do not last forever. The Jurassic had been an age of giants, forests of ferns, herds of titans, skies alive with wings. But as the Cretaceous period dawned, around 145 million years ago, something gentle and miraculous began to unfold. The world that had once been green and ancient began to bloom with color. This was the age when the earth learned to flower. At first, the change was subtle. Small blossoms hidden among the ferns, delicate shapes opening under the sun. But what began as rarity became revolution. These new plants, the angiosperms, or flowering plants, transformed the land forever. They grew faster than their predecessors, spreading seeds not just by wind, but by allure. They invited life to come closer. Bees and beetles, moths and flies, creatures drawn to their nectar, became partners in evolution. Every color, every scent, every shape of petal was an invitation. Pollination had begun, and with it came diversity beyond anything the world had ever known. Forests turned to gardens. Fields shimmered with flowers. Grasses evolved and began to carpet the earth. Where once the air had smelled of resin and fern, it now carried sweetness, the breath of blooms under the sun. The dinosaurs adapted too. Many grew smaller, lighter, faster, built for this new, changing world. Among them were the hadrosaurs, with their duck-shaped bills for grazing on the soft leaves of flowering shrubs. The ceratopsians, like Triceratops, evolved great horns and frills to protect their herds as they roamed the plains. And from small, feathered hunters came a miracle of motion: the birds, the last living dinosaurs. While the great sauropods still wandered the forests, they now shared their world with creatures that chirped, fluttered, and sang. Tiny Archaeopteryx, half reptile and half bird, glided through the warm air. It was a glimpse of what would come long after, a whisper of the skies we know today. The seas, too, came alive with new life. Marine reptiles, Mosasaurus, Plesiosaurus, and ichthyosaurs, glided through waters rich with coral and plankton. Shellfish and ammonites spiraled in vast shoals. On the coasts, early mammals scurried between roots and stones, small and unnoticed, but waiting for their time. The continents were drifting apart now, forming the shapes we almost recognize. Climate zones emerged: warm tropics, temperate forests, even polar forests that glowed beneath long summer suns. The Earth had never been more alive, more colorful, or more full of sound. If you could stand in a Cretaceous meadow, you would hear it: the buzz of insects, the calls of birds, the distant thunder of giant footsteps. A world of blossoms and beasts, of beauty and balance. It was the height of nature's imagination, a masterpiece millions of years in the making. But even masterpieces must fade, and far above, a rock from space was already on its way, a silent messenger that would bring this golden age to its end. The Cretaceous Earth pulsed with life. From horizon to horizon stretched forests, swamps, plains, and shining inland seas. The continents were drifting apart now, each carrying its own evolving kingdom. And across them, in every form and color, the dinosaurs ruled. They were no longer just survivors of the Triassic world. They were its architects, its engineers, its kings. From the smallest bird-like hunters to the largest land animals the planet would ever know, dinosaurs filled every niche, every dream evolution could imagine. The ground trembled beneath the herds of titanosaurs, immense plant-eaters longer than whales. Their footsteps carved valleys in the earth, and their tails could shatter trees with a single swing. Among them wandered the ankylosaurs, armored and low, their backs plated in living stone. Their clubs, heavy as hammers, swung with ancient precision. On the open plains, Triceratops and its kin grazed in herds, their great horns flashing in the sun. They defended their young, faced off against predators, and lived lives not of chaos, but of pattern, migration, nesting, survival. And ruling above them all, with teeth like knives and eyes that burned with intelligence, was Tyrannosaurus rex. Its name, given much later by humans, would mean king of the tyrant lizards, but even in its own time, it needed no title. It was power given form, the perfect balance of strength and purpose. The world had found its equilibrium. The land belonged to the dinosaurs, the masters of adaptation, endurance, and scale. But above them, in the endless blue, a different kind of empire unfolded. The pterosaurs, the first true rulers of the sky, soared on wings of skin and bone. Some were small as sparrows, others vast as airplanes. Quetzalcoatlus, the largest of them all, glided above the coastal cliffs with wings stretching 12 meters wide, taller than a giraffe, lighter than air. They rode the rising thermals, circling silently, their shadows sweeping over rivers where herds of hadrosaurs drank. In those skies, early birds joined them, feathered, agile, quick to dive and turn. Together, they filled the heavens with motion, hunting, nesting, calling to one another across the winds. It was a symphony of wings, reptilian and avian, ancient and new. If you could have stood in a Cretaceous valley at dusk, you'd see it. The air alive with gliding silhouettes, the ground shaking with the slow rhythm of giants. The scent of pine and fern, the hum of insects, the distant thunder of predators calling across miles. It was a living world at its peak, complete, balanced, unstoppable. For more than 150 million years, dinosaurs shaped the Earth's ecosystems, adapted to its shifts, and filled every corner with their forms. They were not monsters or myths. They were life, strong, intricate, and enduring. But in the dark reaches of space, an ending was already forming. A stone, cold and silent, on a collision course with paradise. The world's reign of giants was nearing its final dawn. For millions of years, life had flourished balance. Forests blanketed the continents, oceans teemed with coral and fish, and the skies shimmered with wings. It was the Cretaceous world, full, vibrant, alive. But even the most perfect ages do not last forever. And 66 million years ago, the story of the dinosaurs met its sudden, burning end. It began not on Earth, but far away, deep in the cold silence of space. A rock, 6 miles wide, ancient beyond imagination, drifted through the void. For aeons, it had circled the sun unnoticed. Then, on a day that would change everything, its path crossed ours. When it struck with the force of 1 billion nuclear bombs. The impact site, near what is now Chicxulub, Mexico, erupted in light brighter than the sun. In an instant, forests ignited, oceans boiled at their shores, and shockwaves raced around the globe. Mountains crumbled. Everything within hundreds of miles was vaporized. And above it all, a cloud of ash and molten rock rose higher than the stratosphere, spreading across the planet. Day turned to night. For months, perhaps years, sunlight could not reach the ground. Photosynthesis stopped. The air grew cold, the seas acidified, and food chains collapsed one by one. The great herds of herbivores starved, followed soon by the predators that hunted them. Even the mighty Tyrannosaurus rex, ruler of the land, fell silent. In the oceans, the ammonites, those spiral-shelled survivors of ancient ages, vanished. The vast pterosaurs of the skies disappeared too, their wings stilled forever. By the time the skies cleared, 3/4 of all life on Earth was gone. The age of the dinosaurs, 160 million years of dominance, had ended in a geological blink. But not everything died. Small mammals, burrowing deep in the soil, endured the cold and hunger. Tiny birds, descendants of feathered dinosaurs, survived by scavenging seeds and insects. Ferns, hardy and ancient, spread across the burned landscape, reclaiming the charred ground. Life had been wounded, but not destroyed. If you could have stood in that aftermath, the silence would have been complete. No roars, no thunder of footsteps, only the hiss of wind over blackened stone and the faint stir of leaves returning to the light. Yet, within that silence, something beautiful was beginning. The slow, patient rebuilding of the world. The dinosaurs were gone, but their legacy remained. Written in every bird that soars today, in every creature that walks upright, breathes deeply, or dreams of the sky. From the ashes of extinction rose the seeds of the next great story, one that would lead, step by step, to us. The earth had ended one chapter with fire, and now, in the quiet dawn that followed, life began to write another. When the fires faded and the ash began to settle, the earth was a different world. The skies, once filled with wings, were empty. The forests were gone, the great herds silenced. For the first time in over about 160 million years, the dinosaurs' footsteps no longer shook the ground. And yet, in the quiet places, beneath the soil, inside burrows, hidden among the roots, life still breathed. These survivors were small, cautious, and clever. They were the early mammals, creatures no larger than rats, whose ancestors had lived in the shadows of dinosaurs for millions of years. They had learned to hide, to move silently through the night, to feed on insects and seeds, and anything that could sustain them. When the world burned, that modesty became their salvation. While the great reptiles fell to starvation and cold, these tiny beings endured. They curled together in burrows to share warmth, scavenged what little remained, and waited for the darkness to end. Their hearts beat quickly, their bodies warm and alive, small furnaces fueled by the new power of endothermy, the ability to make heat from within. That warmth became the key to survival. When sunlight finally returned, they emerged into a planet washed clean of giants. The forests were still ash-grey, but ferns and grasses had begun to rise again, painting the earth in green. It was a quiet world now, gentle rains falling on empty valleys, rivers carving paths through new soil. And through this stillness, the mammals began to explore. They were simple by our standards. Creatures like Morganeucodon and multituberculates, soft-furred, sharp-eyed, and quick. Some climbed trees to hunt insects. Others burrowed or leapt through the undergrowth. Their diets were varied, their bodies adaptable, and most importantly, they reproduced differently. Unlike reptiles, they nourished their young inside their bodies and cared for them after birth. Each generation grew smarter, stronger, more prepared for a world that demanded endurance over might. The mammals spread quietly across the recovering earth. They followed the ferns and flowering plants, feeding on seeds, roots, and the insects that swarmed among them. In time, they diversified into forms that would shape all that followed: gliders, diggers, climbers, and swimmers. They did not yet rule the land, but they were patient. They were waiting. If you could have seen one of those early nights, a pale moon over a landscape of ferns, you'd find them there, tiny eyes glinting in the darkness, paws rustling through leaves, noses twitching at the scent of rain. The world that had once belonged to giants now belonged to the small, the quiet, the resilient. They were the heirs of survival. And though they lived in the shadows, they carried within them the promise of light, the future of life that would one day walk, run, and dream beneath the sun. The age of giants had ended, but the earth was stirring once more. The fires had cooled, the skies had cleared, and rain fell again on a wounded world. From the ashes of the Cretaceous came the dawn of a new era, the Paleogene, a time of renewal and rebirth. The continents had drifted far from where they began, their edges surrounded by warm, shallow seas. Volcanoes breathed new islands into the oceans. Forests, once reduced to ash, crept back across the continents in waves of green. Grasses and flowering plants spread into meadows. And where ferns once dominated, towering palms and hardwood trees reached for the sunlight. It was as if the earth itself exhaled, a long, slow breath after an age of silence. And into that silence came the sound of wings. The birds, descendants of the smallest feathered dinosaurs, filled the skies once more. They perched on the new trees, nested on cliffs, and fished in the rivers that had returned. Their songs, the first true songs in the history of life, echoed across the forests, delicate and bright. From their lineage would come every shape and colour we know today. Hawks, herons and hummingbirds, all born from that first flight of recovery. On the ground below, the mammals were changing too. Freed from the shadow of dinosaurs, they began to grow, to explore, to diversify. Some remained small and cautious, living in burrows or trees. Others grew larger, filling the empty roles left behind. Grazers, hunters, scavengers, and swimmers. In just a few million years, the earth saw a bloom of forms. Early primates leaping between branches, hoofed creatures running across grasslands, and sleek predators stalking the edges of forests. The Paleocene and Eocene epochs, the first chapters of this new era, were warm, lush, and abundant. Tropical forests spread as far as the poles, where palm trees grew under midnight suns. Rivers teemed with turtles, crocodiles, and mammals that had never known the fear of a tyrannosaur. Life was rebuilding itself with quiet confidence. In the seas, new giants arose. Whales began as small, four-legged creatures wandering the coasts, wading deeper with each generation until they became masters of the deep. Sharks and fish adapted to the changing waters, and coral reefs blossomed again, painting the oceans in colour. If you could walk through a Paleogene forest, you'd feel the warmth of a stable planet. Sunlight filtering through dense canopies, the calls of birds and monkeys mixing with the rustle of leaves. Everywhere you looked, life was inventing itself anew. This was not the age of domination, but of balance, of species learning to share the planet rather than rule it. It was an Earth without kings, guided only by adaptation and time. The great reptiles were gone, but their legacy lived on, in birds that soared, in mammals that thrived, and in a planet learning once again how to sing. The world had not merely survived, it had evolved. The Earth is never still. Even when the forests seem silent and the seas calm, the planet is moving, breathing, folding, remaking itself from within. And as the Paleogene world gave way to new ages, the Earth began to change again. This time, It wasn't fire that reshaped the planet, but stone and ice. The continents, forever adrift upon their molten mantle, began to collide. India, once an island adrift in the southern seas, crashed into Asia with unstoppable force. The impact crumpled the crust, thrusting up a vast range of mountains, the Himalayas, the highest peaks the world had ever known. To the west, the Andes rose along the spine of South America, while in North America, the Rockies continued their ancient uplift. The face of the planet grew wrinkled and proud, its mountains piercing the clouds. These towering ranges changed everything. They altered the winds, trapped the rains, and carved new rivers through the stone. And as the mountains grew, the Earth's climate began to cool. Rain eroded the peaks, carrying minerals to the oceans where carbon was drawn from the air and locked away in stone. The planet was learning a new rhythm, a cycle of warming and cooling, of abundance and retreat. The great warmth of the early Eocene faded. Forests thinned in the north. Grasses began to spread across the plains, creating open habitats that favored new kinds of life: swift runners, keen-eyed predators, and grazing herds. The world was preparing for the coming cold. Then, slowly, the first great ice sheets appeared. They crept down from the poles, carving valleys, grinding rock to dust. Seas withdrew, coastlines shifted, and temperatures dropped. The Oligocene epoch saw the birth of the first true ice ages, long eras of freezing silence interrupted by warmer interludes. Each pulse of ice reshaped the continents, creating the landscapes we know today. In these shifting climates, evolution quickened. Animals adapted to the cold, growing thicker fur, stronger limbs, and sharper senses. Whales and seals ruled the icy seas. Mammoths, rhinos, and saber-toothed cats evolved in the frozen north. Even as glaciers advanced and retreated, life moved with them, patient and enduring. If you could have stood upon an early Himalayan slope, you would have seen a world in motion, rivers roaring from melting snow, valleys shrouded in mist, and eagles circling the jagged peaks. Far below, plains stretched golden under the changing sky, where herds of early horses grazed and wind whispered through the tall grass. The earth had become a planet of contrasts: warmth and frost, jungle and tundra, calm and storm. It was a restless beauty, sculpted by time and pressure, endlessly creating and erasing. And through these endless cycles, life learned resilience. It bent, but did not break, adapted, but did not vanish. Each new challenge became a teacher, each glacier a sculptor of survival. The age of ice and stone was preparing the world for what would come next, a creature that would not just endure the planet's changes, but begin to shape them. By the time the mountains had risen and the ice had come and gone, the world had changed again. Forests blanketed the equator, and wide grasslands stretched beneath golden skies. Rivers wound like silver threads through valleys carved by glaciers. And in this restless, beautiful world, about 25 million years ago, a new kind of creature began to move among the trees. They were not yet human, not even close. But they were different. They watched. They remembered. They learned. These were the early hominoids, the ancestors of apes, and eventually of us. They lived in the lush forests of Africa and Eurasia, climbing easily through the canopy, their long arms reaching from branch to branch. Unlike their monkey relatives, they had larger brains, shorter snouts, and a curiosity that set them apart. Their hands were skilled, their gaze intelligent. Every movement spoke of balance and thought. Fossils like Proconsul from Kenya and Dryopithecus from Europe tell us their story. They were agile, fruit-eating climbers, walking on all fours along the branches, sometimes venturing to the ground. Their family tree was already branching, experimenting, some evolving toward gibbons and orangutans, others toward gorillas and chimpanzees. Each generation refined the tools of awareness, vision, memory, communication. They were not just surviving, they were beginning to understand. The forests of the Miocene epoch were their kingdom. It was a warm, green world filled with sound, birds calling, leaves whispering, rivers humming softly through the undergrowth. The apes thrived here, moving in small family groups, grooming, protecting, teaching. They were social creatures, bound not by strength, but by connection. Every gesture, every glance, every call mattered. From that unity, something profound began to grow, the roots of empathy. But as the climate shifted once more, the forests began to thin. Grasslands spread, trees grew sparser, and those who had once swung effortlessly through the canopies faced a choice: retreat deeper into the forest, or step out into the open world. Some stayed among the trees, becoming the great apes we know today: orangutans, gorillas, chimpanzees. Others took their first tentative steps onto the plains. They began to stand taller, to look farther, to see the horizon. If you could watch one of those ancient apes sitting high in a tree at sunset, you might recognize something achingly familiar: the way it pauses, gazing out over the landscape, as if wondering. The same spark that would one day build fires, carve tools, and whisper stories was already there, faint but alive. The earth had seen intelligence before, in dolphins, in birds, in cephalopods of the deep. But in these apes, thought took on a new dimension: memory, imagination, choice. The world was changing again, and from these quiet forests, from the patient rhythm of observation and care, would rise a lineage unlike any before, creatures who would not only live upon the earth, but begin to ask why. By now, the earth had worn many faces: a molten sphere, an ocean world, an age of forests, a land of giants, and a frozen orb of ice. But as the last 10 million years unfolded, its contours began to settle into something recognizable. The continents took their modern form, the climates found their rhythm, and life, endlessly reshaped, began to resemble the world we walk through today. The great mountain chains had already risen. The Himalayas crowned the roof of the world. The Andes traced the spine of South America, and the Rockies split North America in two. Oceans carved deep channels, and currents began to flow in steady patterns that would one day define our weather. The world had become familiar in shape, but more than that, it had become balanced. Forests now stretched across Europe, Asia, and the Americas, filled with creatures we might recognize. Deer, elephants, rhinos, and great cats moved through the grasslands. Birds sang from the canopies. Rivers teemed with fish, frogs, and turtles. And in the oceans, swam whales and dolphins. The new rulers of the deep descended from ancient four-legged wanderers. Everywhere, ecosystems worked in quiet harmony. Predators hunted, scavengers cleaned, seeds spread and bloomed again. The circle of life, once fragile and experimental, had become refined, resilient, self-sustaining. It was during this time that the savannas of Africa took shape, vast golden plains where herds of grazing animals thundered across the horizon. Here, the early hominins, descendants of the forest-dwelling apes, began to walk upright. They learned to use tools, to gather food, to protect one another. For the first time, a creature stood on two legs and looked at the sky, not just as a place to live beneath, but as a mystery to be understood. The earth was ready for them. The climate offered challenge and opportunity, seasons to test endurance, droughts to teach adaptation, abundance to reward ingenuity. Everything that had come before, every extinction, every collision, every rebirth, had shaped the world into this precise moment of balance. If you could walk through that late Miocene or early Pliocene landscape, much of it would feel familiar. You'd see rolling grasslands under blue skies, the shimmer of heat on distant hills, and flocks of birds tracing graceful lines through the air. The wind would carry the same scents: soil, grass, water, life. It would sound like home. But beneath that calm surface, evolution was still whispering, still shaping the future. Brains were growing larger, hands were growing steadier, voices were beginning to form. The earth, once ruled by giants and fire, now belonged to thought, to the slow unfolding of awareness. And as the sun set over those ancient plains, a new dawn waited beyond the horizon, the age when life would not just live upon the earth, but begin to know itself. The earth remembers. Even when mountains crumble and oceans shift, its memory remains, pressed into stone, waiting for hands to uncover it. Each grain of sand, each buried shell, each whisper of a bone tells a story older than words. These are the fossils, the lasting memories of lives long vanished, the silent witnesses of all that came before us. When you hold a fossil, you hold a fragment of deep time, a spiral of a shell that once swam in a Cambrian sea, the imprint of a fern that grew before flowers existed, the footprint of a creature that walked through mud 100 million years ago and never knew its step would last forever. These are the Earth's archives, written not in ink, but in pressure and patience. Fossils are not just bones. They are moments, frozen mid-breath, preserved by chance and time. A fish caught in volcanic ash, a leaf pressed under ancient silt, a single tooth gleaming in rock, telling of an animal's hunger, its death, its descendants. Through them, we see not only what life was, but how it changed, adapted, survived. Paleontologists read these stones like poets. They see patterns in cracks, stories in dust. From fragments no larger than a finger, they reconstruct entire worlds. The rise of oceans, the march of forests, the thunder of hooves that no longer sound. And every fossil discovered connects the past to the present, revealing that what once lived still lives in us. When we study the curved spine of a dinosaur, we see the echo of that same structure in birds. When we trace the bones of ancient mammals, we find our own blueprint. Hips, ribs, skull, hand. Every bone in the human body carries the signature of deep ancestry, shaped by the same forces that built every creature before us. We are mosaics of prehistory, walking fossils, made of memory. Even the smallest fossils, a pollen grain, a shell fragment, are like pages torn from the planet's diary. Together, they tell of tropical forests where deserts now lie, of shallow seas where mountains now stand. They remind us that the world we know is only one version of itself, one heartbeat in a cycle of endless transformation. If you've ever stood in a museum and looked into the hollow eyes of a fossilized skull, you've felt it, that strange mix of awe and connection. It's not just curiosity, it's recognition. Something in us remembers the deep silence of those ages, the weight of the world before our time. Fossils are proof that nothing truly disappears. Life changes shape, time reshapes life, and in the end, all becomes one with the earth again. The bones we find are not just relics of death, they are reminders of persistence, of rebirth, of the endless conversation between what was and what is. The earth remembers, and through fossils, it lets us remember too. Not every story leads to us. For every creature that gave rise to another, for every lineage that continued, there were countless others that ended quietly, forgotten, unremembered, but never meaningless. These are the side branches of life's great tree, the worlds within worlds that shaped evolution only to disappear. They lived, they thrived, and then they were gone. Yet the earth remembers them all, in fossils, in DNA fragments, in the quiet echoes of their design that still ripple through living things today. Imagine the seas of the Cambrian, full of creatures so strange they seem born from dreams. Opabinia, with 5 eyes and a trunk-like snout, gliding through the water like a wandering thought. Hallucigenia, a tiny worm walking on spines, upside down for half a century before scientists realized which side was up. They vanished long before trees existed, yet, in their brief reign, they experimented with what a body could be: sight, movement, symmetry, the first drafts of life's endless imagination. Then came the trilobites, who ruled the oceans for nearly 300 million years, evolving into thousands of shapes: hunters, scavengers, swimmers, before fading away. Their world ended in silence, yet their design would inspire the jointed armor of insects and crabs that still walk today. They are gone, but their blueprint endures. On land, forgotten forms flourished too. Before mammals rose, the earth belonged to the synapsids, reptile-like beings with dog-like jaws and sharp teeth, ancestors of nothing we know, yet kin to everything we are. Some had fur, some had warm blood. They were nature's early experiments in endurance, in warmth, in motherhood, and from them, the idea of the mammal was born. Most vanished in the Permian fires, but without their trial and error, we might never have existed. Even among the apes and humans, side branches sprouted and fell away. Paranthropus, Denisovans, Homo floresiensis, each with intelligence, strength, and promise. Each vanished, leaving behind only a trace, a jawbone, a fingerprint, a single strand of DNA woven into our own. Their stories end abruptly, but their presence lingers, quiet as breath. If you could look at life from above, not through time, but through connection, you'd see not a ladder, but a vast, branching web. Every creature that ever lived sits somewhere upon it, each line crossing and fading, some leading to the present, others dissolving into the dark. But every one of them mattered. Every one carried the flame forward, even if only for a while. The forgotten lineages remind us that evolution is not progress. It is art. Trial, error, beauty, disappearance. It is life experimenting with itself, again and again, across eternity. And though most of these beings are gone, their echoes live on, in the curve of a fin, the tilt of a skull, the rhythm of a heartbeat. We are the sum of all their chances. The last note in a song that has been playing since the dawn of time. If the history of the earth were a single day, life would begin just after midnight. Simple cells stirring in the dark oceans as the planet cooled. For hours, nothing but silence and slow creation. Then, as dawn broke, multicellular life would appear, filling the seas with color and motion. The dinosaurs would not walk the land until late in the evening, around 10:30 p.m. And humans, we would arrive only in the last seconds before midnight. That is how young we are, how brief our story truly is. The Earth is 4.5 billion years old. Our species, Homo sapiens, about 300,000 years. Civilization, the part we call history, barely 5,000, a single blink in the eye of time. The rocks beneath our feet have seen entire worlds rise and vanish before we even learned to make fire. To grasp deep time is to step outside of ourselves. It is to realize that mountains are not permanent, that oceans wander, that even stars come and go like seasons. It is to understand that every breath we take is borrowed from an atmosphere shaped by microbes long before we existed. In the great timeline of life, dinosaurs ruled for over 160 million years. Sharks have patrolled the seas for 400 million. Dragonflies have been flying for twice as long as there have been flowers. And yet, here we are, fragile, fleeting, able to look back across the eons and understand what no other creature can, that we are temporary and that time is infinite. When we find fossils, we like to imagine that we are looking backward, peering into a vanished world. But deep time doesn't flow like a river. It's more like an ocean. Every layer of rock is still here, stacked beneath us, every age pressed gently into the next. We don't stand after history. We stand upon it. Every step we take is across the bones and stories of everything that ever lived. If you could stretch out the timeline of Earth's history along a road 1,000 miles long, human civilization would occupy only the last few inches. All of recorded history, every word, every empire, every song, would fit into a space smaller than a breath. And yet, within that breath, we have learned to split the atom, map the stars, and speak to one another across the planet. We have remembered, imagined, and dreamed more in seconds than the Earth itself might in 1,000 millennia. Deep time humbles us, but it also connects us. Because in that endless scale, every life, every heartbeat, every memory is part of the same story. A story of a planet that keeps creating, and of life that keeps finding a way to begin again. The Earth is ancient beyond measure, and we, small, curious, brief, are its moment of awareness, its single, shimmering thought before the clock strikes midnight again. Beneath our feet, the world is alive, not in the way forests breathe or rivers move, but in something slower, deeper, a heartbeat made of fire and stone. Every mountain, every ocean floor, every continent that drifts silently across the globe is part of a grand and ongoing motion that began billions of years ago and still continues, unnoticed, beneath our days. The Earth's crust is not a single solid shell, but a mosaic, tectonic plates floating atop a sea of molten rock. They collide, slide, and pull apart, shaping the world in cycles so vast that even civilizations come and go before one is complete. Mountains rise where plates meet, volcanoes erupt where they break, and deep trenches form where one is pulled beneath another. Earth recycling itself, one layer at a time. Every few centuries, these forces remind us of their presence. A mountain shudders, an island is born, a city falls silent as the ground moves beneath it. It can be terrifying, but it is also creation, the same creative power that built the continents we walk upon. Volcanoes, though fierce, are the planet's breath. They release gases that built our atmosphere, minerals that feed our soils, and heat that drives the deep currents of the ocean. Without them, Earth would be cold and barren, a silent rock drifting in space. Each eruption, each plume of ash, is both destruction and renewal. The Earth burning away the old to make room for the new. The continents themselves still drift. At roughly the speed that fingernails grow, they journey across the planet's surface, gathering into supercontinents only to break apart again. In 100 million years, Africa will merge with Europe, Australia will move north, and a new ocean will open where now there is land. The face of the Earth is a painting that never dries. Even life today is shaped by these hidden movements. Volcanic islands give birth to unique ecosystems, places like the Galapagos, Hawaii, and Iceland, where isolation becomes a canvas for evolution. Earthquakes reshape rivers, reroute migrations, and create lakes where new life can begin. The fertility of volcanic soils sustains entire civilizations. The rice fields of Java, the vineyards of Italy, the green slopes of Japan's Mount Fuji. We live upon a restless planet, a place where change is not an interruption, but a constant. Every pebble underfoot, every coastline we trace, is the work of a force so patient it measures time in continents. And when we feel the ground tremble, when mountains smoke or oceans shift, we are reminded of something ancient and humbling. That this world is not ours to command. We are simply guests upon its moving skin, here for a moment, while the Earth continues its slow and magnificent dance beneath us. The story of the Earth is not just about what came before us. It is also about what continues after, the quiet rhythm of change that never stops. even when we stop noticing. For billions of years, the planet has lived through cycles of creation and loss, each ending becoming the beginning of something new. In that way, life before life was never truly gone. It was simply preparing for us. Every element in our bodies, the carbon in our skin, the iron in our blood, the calcium in our bones, was forged long before we existed. Some in the hearts of ancient stars that exploded before the Earth was born. Others in the molten depths of a young planet still learning what it meant to hold oceans and air. We are built from the dust of that ancient life, assembled by the same chemistry that once shaped worlds. We are, in every sense, the continuation of what came before. When we study the deep past, the first cells, the forgotten lineages, the endless rise and fall of worlds, we begin to see that survival is not about strength. It is about adaptation, patience, and renewal. Every mass extinction, every catastrophe, has cleared the stage for new forms to emerge, and so it will be again. Humanity stands at a strange point in that cycle, young, powerful, and fragile. We build cities that shine brighter than the stars, but we are still children of the soil, dependent on the same sun, water, and air that nurtured the first algae. The story of life before life reminds us that balance is everything. When life forgets its harmony with the earth, the planet simply begins again, slowly, silently, patiently. But it also teaches hope, because no matter how many times the world has burned or frozen, life has always returned. Not the same as before, but wiser, more complex, more aware. Perhaps that is the true purpose of time, not to destroy, but to refine, to teach every living thing how to become something more. If you could listen closely enough, you might still hear it, the heartbeat of deep time beneath our own. It reminds us that our story isn't separate from the Earth's. It is the latest verse in a song that has been playing for 4.5 billion years. A song of dust and water, of fire and breath, of endings that always give birth to beginnings. So, when we look ahead, at our fragile future, our warming world, our uncertain tomorrow, perhaps we can take comfort in what came before. Life endures, it transforms, and even when it seems lost, it always finds a way to return. In the vastness of time, we are only a flicker, but in that flicker, we carry the memory of everything that ever lived, and the potential for everything still to come.